Hey, welcome to another coding session. We're continuing through our list here. I'm hoping that we can kind of finish off the big ones. I'm being a bit ambitious today, I think. I wonder if we can get both of these done in one go. I think it'll be a bit of a challenge, but let's see if we can. Before we get stuck into that, there was this one thing in the grammar that I noticed that we should have fixed and didn't, because we merged these literals. So there's no such thing as a C string literal, there's just a string literal. So let's get rid of that. And actually, maybe we'll kind of explicitly, every time, call this a string literal, number literal, Boolean literal, compound literal. And because I'm a stickler for ordering, I'm going to go with this ordering. I think that looks nice for no apparent reason. So we need to fix this up here and also reflect that same ordering and take out our C string. So we have Boolean number string compound. There we go. Cool. Okay, so that cleans that up. So let's get stuck into our two main features we want to do. Optional return values. It really kind of bothers me that in places like this, we have to return true and have a return type of bool, because otherwise this is not valid code. So let's make that valid code. That should be valid. And I might just go like that. I kind of like that formatting. I feel like that's a bit cleaner. Okay, so let's make this work. I think the major thing that we need to do, I had a bit of think about this, is we need to give the parser some context. Because at parse time, currently when we go to our return, where is it? Parse return, here it is. So we use we parse the return keyword and then an expression. And we could make this optional, but the problem with that, just making that optional, is that, like this example here, this is a right-hand side expression. Well, actually, no, it's not. This is an assignment now. But let's say we had do stuff. This is a valid right-hand side expression. So how should it evaluate this? Should it be like this, or should it be like this? You know, white space doesn't mean anything in our language. So is it saying return the result of do stuff, or is it saying if we don't return, then the next statement is do stuff? And to disambiguate that, I think we need to provide some context here. So we're going to introduce a parsing context. And this parsing context is a struct. And that just has one member in it, which is a Boolean, which is, how to say it, like return value required or something like that. And so now we can say if return value required, then we parse an expression. Otherwise we don't. So then it should be able to know from the signature here that we do not require a return value. So the return statement should be just this keyword. And then it moves on to parsing a new statement. That is how it should work. So we need to actually set this somewhere, and we need to pass it on. You know, here we need to provide a context. So we're probably going to have to propagate this to like quite a lot of procedures. So here I think we can just define the context, parsing context, like so. So a parse statement works, but now we have a lot of places where we need to pass it along. So yeah, this is probably going to propagate to a lot of places. Anywhere else in here? Yes, yes. So now that needs it. And now if we come down here, it's required in here. Where else do we need it? Here and here. And parse scope needs it. It's needed here. So probably quite a few places up here need it now. Yeah, basically all of them. And what do we got here? Parse assignment needs it. So we passed that along. So we need to give it to parse assignment now. And I see one more error down here. Parse compound literal. I think when we're parsing a literal, the assignments within literals will never do calls. Or, no, there will never be definitions of procedures. No, wait, what is it we're looking for again? Returns. Yeah, there should never be return statements within compound literals. I might even restrict it at some point, so it's like a more restricted assignment. But there should never be a return statement in here. So I'm just going to make a dummy context and pass that in, like so. So to avoid having to pass it all the way down to this procedure. So that seems to be all happy now. But we still, like we have our parse return which uses this, but we still need to know whether it is required or not. And that should be part of parse procedure, I guess. It's a parse procedure, parse program. Is it parse assignment? I guess it would be parse assignment. And if we're parsing an assignment where the left-hand side is a procedure type, let's have a look at how we do it, like up here, where we detect. This is how we tell if it's a procedure. So maybe we should do something similar here. If the left-hand side is a member, we need the type node. So if left-hand side is not a member and it is a procedure, I guess then we will say return value required equals, and then we have to figure out whether it does require it. So I guess it would be the length of this children is greater than 1. Or maybe I'll even be specific and say equals 2. So this procedure node, the first child is the parameters, second child is the return. So if it has 2 children, that means it has a return, and the return value is required. So I think that should work properly. And then in type checking, when we're type checking a return, where is our return? Assignment, scope, return. Then procedure, so if procedure has no return type, well, I think parsing is going to kind of take care of the errors now, because parsing will require us to have a right-hand side. It will require us to have an expression. Like, it'll require us to have something here if it's needed, and it'll require us not to have something there if it's not needed. So I think those cases are taken care of. And I think that's kind of what this was getting at. So I think we can get rid of that. And the only thing about type checking a return is to type check that expression. And the expression only exists if we have a return type. Which we can probably figure out before we go in here. So we can probably use this node children. If it's greater than 0, because a return will only have a child when we parse the return. See, it creates a node, and then it only adds a child if we have a return value. So if it doesn't have children, we don't have to do anything. If it does, then we type check it. I think that's about it. Do we need to do anything in generation? Probably. When we're generating, where is it? A return. If we're not in a procedure, then it always has a return value required. But I don't think we said that, did we? We should do that. So that, yeah, when we first enter the program, a return type is required. So that's always fine, but this one, we might not have to do this. So again, we can say expression location. Well, that depends on the expression node, which might not exist. I think that's right. So then again, we can say if the length of node.children is greater than 0, then we do all this stuff. Otherwise, all we have to do is skip to the end. Expression type node. We need now, let's put that at the top. And this is about the return. I feel like it's nice to put the expression first, then the return, like from to. From to. There, I think that looks nice. And I think that's all of it. So if we do that, yeah, that works fine. I think there is one other place in here. Well, this should work fine now. That was a problem because it was wrapping it in a return statement, but it shouldn't do that anymore because it doesn't need a return. Well, actually, let's just double check that. That would be an assignment, I think. Here it is. Yeah, so only if return type is not nil. Yeah, so we kind of already had something about that, so it shouldn't get wrapped in a return. So that's fine. And wasn't this somewhere else? Here. So this, go like this, maybe, oops. Maybe you can put that on the end. Yeah, so that should all work. Cool, that all works. Pretty happy with that. I don't think there's anywhere else where we have this kind of problem. Don't think we had anything in here. Okay, cool. While we are fixing stuff up in here, a little side quest. Let's see if I'm bitten off more than I can chew. But this part here, we have not now, so we should be able to just do this. But the problem is cannot invert type call. So this is to do with our when we have a call node, it has a type call, and it's like it has a complex type which is the same as the procedure. So if we go to type checking of a call, see right down the bottom, basically we copy the, this is type node. Let's be a little more specific. Well, it is type node, I guess. No, this type node. This type node should be the procedure type node. That makes it clearer here that it's basically copying the procedure type node and then setting the name of it to call. And because we do this, we have then this get type result business. Where is it? Get type result, whose main job is basically to look for a call, and if it finds one, then get the type, its return type. So this is happening because there is a place where we're not calling this, but actually what I've been thinking is we shouldn't do this. We should just put the return type here, I think, instead, because the procedure node is the first child. So we can just get all that type of information from there. We don't need to duplicate it on the call node. We can just give the call node the return type, which I don't think we actually grab. So let's say if the procedure type node children, if there's two of them, that means there's a return type. And it's that one. So now the type of the call is the same as the type of the return type of the procedure. I think that's better. I don't think we need to have call. Let's have a look for anywhere where we have call. So there's only two places here, which is us creating, like we're going to change this as well. And here, which is like where we say like, you know, get the type result. So let's just get rid of this procedure. And up here, again, we just want to give it like a nice simple type. So we're setting two things. The type node has a child, which is the procedure node. So the procedure node is a type in this case. This is when we're doing conversions. It's like a special case of a call. So it is as simple as that. So that makes the type, because that's basically all we're doing, right? We create this type node. This is a whole bunch of stuff to create the type node, and then we set it on here. But really, we just want the return type, which is the type itself. It's a bit funny. Now, how does our get type work? Does it just grab the last? Yeah, it grabs the last. Okay, good. Because I think this is going to be a bit strange because it has this node. We have a child here, which is a type. Then it'll have another child, which is the parameter. And then it'll get a new child, which is the type. But two of those are type nodes, which is where the confusion comes in. But it's always the last node to be added, which is considered the type. Okay, so I think that's all good. And now we don't need to worry about this stuff. And actually, I want to change this. So just do that directly there. I think that's nicer. And I guess it'll be the same up here. Whoops. Here we can just use expected type node. And this is type node. And so we can put that in there. Cool. Simplified that a bit, that's nice. Hopefully that error goes away. Here we can just get rid of this. Okay. Oh, I should have done a proper copy replace there. Yes, I really should have. Okay. Did that fix it? We still have an error. We still have one of these. And expression type node. Probably start expression has the same thing. Yep. How about that? Still have one. And another one. Code just looks so similar. I didn't realize that it had jumped. Okay. New type node is null. Upgrade types. Upgrade types, right hand side. So type node and expected type node are both null. Oh Jesus, what did I do? What have I done? Expected type node should be null, that's fine. But this is resolved to null. So probably what I've done wrong is so if there's no return type, to the call, that means that now there's, like previously there would be still a type, would be call and everything. It would resolve to null though. Like I think this is totally fine. We're not expecting anything, we're not getting anything. I think that's totally fine. So maybe we can just say like, if that does not equal null, like if it's null, there's no need to upgrade types. And if it coerced to null, that means that they're both null. Okay, generate call. Yeah, so this is where we want the procedure type node now, which comes from the procedure node. I keep doing that. Let's rename this properly. There we go. Try that. So now it should be getting the type information from the correct place. And now it's this issue. Contains allocations. Again, because if we have a call node, it's actually the first child is where we're going to get the type information of the procedure itself. And that's what the directive would be on. So we'll try that. Oh, that needs to be address. Still have an issue. Let's see what it is. Oh, still not happy with this. If it's a call and the procedure. So I'm guessing here that it's a call with 3 children. First child is I32. First child is the type I32. Really? So I guess that means that that's a conversion call, right? That's a conversion call, converting to I32. And in that case, well, in that case, so the first one is an I32, but there's 3 children. The third one should be the actual type. So if we go back to our call, yeah, because we added that as our third child. That's the first child. That's the second child. Now we're adding a third child, which should also be the same. It should be an I32. So I don't think that should be a problem. But we're getting the type of the first child, and the first child is this guy. Yeah. It's not a procedure, actually. It's just an I32. So let's just say not is type to avoid that. What else we got here? Okay, So when we do a conversion call, again, we're getting the wrong type info. Let's just to be extra clear, say, here's our procedure node, and we're getting the type from it, like so. Let's see what it says now. More issues. So it's a procedure type, params, param identifier, param type. So, oh, the procedure type node is null. Okay. So I think we did still... Yeah, we've kind of been working around, like, where did we work around it? Maybe it was in generation. Yeah, see, this we've been working around the fact that there's no procedure type. But maybe we do need to give it like a proper procedure type. I think that was the only place that we kind of worked around the fact that it was... I hope so, I can't remember exactly. I just want to double check that we haven't done anything we don't need to do. Any extra checks or something that I put there. This one might not be needed anymore. Let's see. I think it probably will. We'll just take it out for now just in case it was not actually needed. This is the actual call. That's all good, and we took care of that. Generation. Most of this is just removing the fact that it was a type result. Yep, and that was the return stuff. Probably should have done a commit after that for all the return stuff, so make it clear what we're changing now. Procedure, get type. Yeah, I think we just changed the names in here. Basically, this is where we are now, having the issue. We haven't done anything special here yet. Okay, so I think the thing that I was saying we wanted to fix up was up here, basically. Like, we create this type of the procedure, but we actually want to add it to the procedure node. I guess that's a bit weird, but I guess we do actually want to do that too. Because that's the return type. And because that's modifying the procedure node, let's put that up here first. Okay, so now the call has the correct type, which is the return type of the procedure. And the procedure node, which we've just added, also has a type node of its own. Okay, I think that should resolve that issue. This is where we were here, and it's like everything is null. So yeah, I got a bit too overzealous when I removed that, but I don't want to have code that is not required. There we go. Okay. That's working. We have a rogue window to close. So that was a bit of work, but I think it's a bit cleaner now. So let's do a whip. Okay. Okay, so what was the next thing we're going to move on to? Modules. Okay, so we did this as well. So when I say modules, I mean like if you're using things from a separate, each source file is going to be a module. It's kind of, if you use JavaScript, it's kind of JavaScript-ish. So in here, I'm using standard lib. So I'm going to do something like this. And then everything I use from the standard lib, like I think vec3 is in there right now. Thread pool, this thread pool stuff, all of that's in the standard lib. So I'm going to need to prefix it with standard lib dot. That's the idea. So let's see how we can go about doing that. In our main, hopefully we'll uncomment this at the end too. So our compile at the moment is sort of like doing the standard lib and then compiling our current file. I'm going to extract this into a new file. We're going to call it import module. It shouldn't generate. And it shouldn't have standard lib stuff in here. That's also standard lib. So we have import, I think it's core format and core OS. Well, although if it's just exits, we should probably just return a bool from here. Like so. Maybe we'll give the name. This has file info, so it kind of already has the name. Maybe we'll fix that up later. So this is more like parse module, I guess, and type check module. Don't know why it doesn't want me to rename that. Yeah, I don't know why it was not happy with me renaming that. Okay. So now the extra thing that's going to be in here is I want to have, God damn it, that's annoying, a module struct, which is going to, what is that going to include? In my head it was necessary. And we haven't imported modules map. And if name is in imported modules, we just return true, there's nothing to do. Otherwise we do all this stuff. We tokenize and parse and type check it. And edit. So I think here we need to create a module pass the nodes in. So I guess this is going to have nodes. Dynamic. And we're going to pass in a pointer to the module. Like so. So when we type check a module, we get a module pointer. So the module also, that's right, the other thing I wanted to put in the module was context. Why are you not? Well, hopefully you're happy with that. It should be allowed. That's a pointer to a module. Maybe that's why I was unhappy. So go module dot. It's just in there. I think that should be happy. And this is module.nodes that we're going through. That'll be module.context. And module.context. Yeah, so when all is said and done, when we've finished importing the module, we have something that has all the nodes and also the context from it. So we know the identifiers in it. That's the idea. Now in main, when we compile, essentially, we are going to import the named module. Doesn't actually return it, but if it fails, we can say failed to import module name and exit. Does that need an NASM path? I don't think it does. So that cuts out basically all of that stuff. We import a module and then we generate a program from it. Module like that. I'll pass in a pointer. Don't know if that's going to cause any errors. Yeah, okay. So that's that part of it. Now when we're type checking, we're kind of, we have this import module thing. So we have not yet processed the standard lib file. We've only imported this module, the main module. And then while we're type checking that main module, I'm going to add another loop here before the types, which is going to search for it's going to search for assignments where, yeah, I guess we can say it's not a member. It's not really the important part though, is it? The important part is the right-hand side So I guess we need to say that the length of children is greater than 1. So we have a right-hand side. This is the right-hand side node. That right-hand side node should be a call. So if we get the child of that, then we should be looking at the name of the thing we're calling. And if that is import, then it's an import. And if we have an import, what do we want to do? We want to do import module. So we need to get the name and the source. So the reference is, yeah, in our modules we need to keep track of these references. Or is it in the context? Let's put it in the context. So that's string to string. Is it part of the type checking context though? Maybe put it in the module. Module has references to other modules. That makes sense to me. So the reference that we're talking about now, that's like the left-hand side node. That's the reference. And the name, we're just going to do like a really simple version of this to start with. It's going to be quite naive, but it should do the trick. Because when in main, when we were doing the standard lib stuff, it was source/standard lib. So let's make a new directory, standard lib, and put standard lib in there. Later we'll divide it into more files, so we'll look not so stupid. So when we're doing this, we need standard lib /reference .bang. That gives us our name. And to get the source, how do we get the source here? Like this. Failed to read module file. And then we have the source here. So if we come across a module import, then we do it. Now we're specifically looking at types. Now we're specifically looking at procedures. Maybe, I'm not sure if this is the best place for it, but when we're type checking an assignment, or is it generation? What I'm thinking of is when we generate an assignment, here it is. We're making sure the left-hand side is not a type. Well, let's just see what happens. I think we're going to get an error. So the right-hand side doesn't necessarily have a child. Yeah, in this case, it's a number. So maybe we need to say type equals call. We should probably say that. And Yeah, once we have a call, we know that that would be there. So I think that should be better. Failed to type check module. I think that's in here. Need this F. And failed to import module also. These need Fs, and that needs a false. Failed to import module. There we go. That's better. So import is not defined. That makes perfect sense, actually. How do we get? Well, I guess in type checking we should define it. You know, kind of like we define this stuff. Let's put it here, I guess. Import is a keyword. Import. So it's a procedure. It takes a single parameter. I'll call it name, and that parameter is a string, and it returns a module. Yeah, let's try that. I have a feeling that this string guy won't actually work. Probably need to replace it with the actual string thing. Yeah, any string and string are not compatible. Probably it needs to be probably module now, isn't it? Module dot context dot identifiers string to get the right type information. Okay, now get time of day is not defined in file. That makes perfect sense. We need to, because we need to go to standard lib. But that's not going to work yet. So now it says it's not a member. So let's go to our type checking and figure this out. Index identifier. So here's our not a member stuff. Let's see what information we have at this point, because it's doing a switch on this child type node, which has type module. So we should be able to let's maybe put this in alphabetical order. Should be able to add module here. And we want to find the members of that module, basically. So I guess child node, yeah, is the name of the module. Oh, this is where we need the reference, right? I talked about references before, and I put it in the module, but I think we actually need it in the context. And we didn't actually put it in there. So once we've figured out that everything is all imported properly, we need to append no, not name, reference. Oh no, references is a map. So this is this reference, this is the name, this name that we use it by, and the name is like the fully qualified name. Where are we? This is the fully qualified name. So in our imported modules list, this is the name that it would have. Okay. Where were we? Up here. So now we should say like if not child node dot value in imported modules, or well, I guess in references. Then we could say like module has not been imported. Like so. Then we can say, so if it is in references, that means that an import succeeded. So I think we can assume that this is going to succeed. And then we need to map from references to proper names. So there's our module, get the pointer, why not? And then we need to verify not member found. So I guess we could say like member found equals module.context.identifier. Well, it's node.value in. Oh, we don't have found member at this point. Okay. So if node.value is not in the identifiers, then we say it's not a member. Could be better, but that'll do for now. And then, so if it is a member, then finally we want to apply our type information. That's the whole point here, is to apply type information to the node. And the type information would be get type of this. What if that is a type? That could be an issue. We need to dereference. Let's see what happens now. Okay, we're trying to auto dereference. Left-hand side, type check expression. I have a feeling this is, oh no, this is an index. Whose child is another index. Whose child is data. We've come across this before, and I think it was to do with type information. Yeah, because data is a vec3, but vec3 is defined, well, I don't want to always, in here. We could redefine it in here. Actually, maybe let's do that for now. We'll redefine it there. Do we still have the same issue? Oh no, this is pull, thread pull. So this is not a very nice error. It's just failing to auto dereference, but really, I think it's because this type information is not valid. So we should be checking whether the type of information is valid. And I think it's here when we resolve types. So this part here says we've resolved a type. So if we get to how do we know that that's a type though? I guess when we're parsing, if we're parsing a primary, we come across an identifier. Where is it? Where's identifier? Here we are. And if the primary type is type, then maybe we should make this type as well. We still want to go in here. So we'll go in here for types as well. But if we know we wanted a type and we didn't get one, how do we know that we didn't get one? Yeah, how do we know that this didn't happen? I guess we need to have a Boolean or something, like found type equals true. So if we knew we wanted a type, we didn't find a type, that gives us a chance to, I don't know if this is really the best way to do it, but where's an error? But that gives us a chance to say, like, failed to resolve type. Type was not found. Yeah, let's try that. Okay, so a whole bunch of procedures in an array. These are like, they should not be found, and raw. Well, we don't need to do this pulling because we return. We return if we found something. So if we got here, we didn't find something, but we do need to check. Maybe we can just say, ignore these, because these are like incomplete types. Just lucky I did put this on everything. I guess that's a character. Okay, see, that's better. Type thread pull was not found. So actually, I part of why I did that is because I didn't want to have to handle it for types, but we're going to have to handle it for types because we need to do it here. Boomstick 3 will start. Get time of day. I'm probably going to miss some stuff, but print line, assert, print line. There we go. A type primary cannot access a member. This is no longer the case. Where's the member stuff? Period. So now a type can, because this is like here, this is a type primary, but it can have a member in it. So we're going to allow that, which is a grammar change. So let's just update our grammar quickly. So we need to have this dot RHS primary for the type primary, which is the one below. Type primary, I don't know why that's in brackets actually, it didn't need to be. Now it does. Now because we have the or, but it should be type primary. Okay. I think that's all good. We can do dot type primary now. So let's have a look what error we get now. Type vec3 was not found in file. So I think when we resolve types, where are we? I feel like we should have more changes. Yeah, when we resolve types, we don't only want to look in here. We also want to look in the other modules, which is what we kind of do here. I'm just going to copy and paste for now. It probably should have extracted that, but so let's say, you know, if it's in thing, we'll do this. Otherwise, well, I guess we can say like if is member, then we get the child node. And we do this with it. We look for it in the references. We get the module out. We know that it's in there. get the identifier node. And if it's a type, then we set it. Otherwise, if it's in the identifiers, we just do that. Okay, let's try that. So it should grab it from the other module. Module message has not been imported. Okay, now it's trying to do too much. So, well, yeah. So maybe we should actually be doing this, like just going, instead of giving errors, I guess I hadn't thought this through. Maybe we should just be saying like this. So try to find the references. If we can, then we try to find it in here. And if we find it, that's great. Otherwise we fail. Maybe that's better. Type vec3 was not found in file. So it didn't go into here. Do we ever get into here? Okay. So if we get time of day, thread pool start, broomstick, thread pool wait, get time of day. I'm not seeing any types here. Yeah. It's not doing it for types. Ah, because is member is for types only. So maybe, Jesus Christ, where are we? So maybe we need to do something a bit simpler and just say like, if we have children and that child is an identifier, then we do it. Because in this case, it can only be direct. Okay, so let's put a breakpoint there, see if that works. So for these procedures, thread pool start, broomstick. Still not confident. I don't see any types in here. If it's identifier or type. Why would this not be working? Could it be a type? Maybe it's a type now. Good time of day. vec3. All right, vec3. Boom. So that should hopefully work. Okay, there's just one vec3 left. Probably I haven't prefixed it yet. It was on line 66. Yeah, just need to prefix that. At 125, it says module has not been imported. So that's probably a case of, because it's in a procedure, we need to do our copy copy type checking context. Here we don't have any condition, we just copy everything. When we go into a procedure, print is not defined. Yeah, need to prefix those. Also I to A. Standard lib is not defined 161. Okay, why is it not defined in there? That's interesting, because it was happy up here. Oh, that was not in a procedure actually. But I would have thought this. I would think that this would do it. Ah, but I think when we go back up, do we need to? No, references can only be at the top of the file. I'm making it right now. So for all of our references, we copy it to the child context. Standard lib is not defined. Let's find that and see why that would be happening. Yeah, actually that makes sense. I'm kind of surprised that it's worked up till now. If it's in references, it should be a module that we're talking about. Yeah. So that's when we come across some new. Oh yeah, I guess in this context here, you know, that variable is defined, so we're using it directly. But now when we go into a procedure here, this is like, the compiler's like, I don't know what that is. So we need to tell it that's a module. This is probably, we're generating an assignment that we should not. Yeah. Yeah, I nearly did this earlier, hey. So if we get the type, of the left-hand side, which is what we do down here. So if the type of the left-hand side is not a module, if it's a module, there's nothing to generate. I think, something like that. Seems like we're still, yeah. So left-hand side type is module. Ah, so if it is a module, there's nothing to do. Had that backwards. Okay, we have a bunch of undefineds, and that's because we are not generating. When we generate like our assignments, we're only doing it in the current, for the current module. But we need to do it for all the other modules which are referenced, I guess. So, okay, we're at now 20. It was a bit ambitious to try and do all this in one go. And this this module's implementation is quite naive. I think I'm sort of coding in a way that's like going to work right now, but as soon as we try to do something more advanced, it's probably going to fall over. So I guess we need to pass in the nodes. And the context. Nodes is pointer to dynamic AST nodes. Context is pointed to a gen context. So we do the assignments, but before we do, we're going to loop through the references. And yeah, see, this is another thing that's quite naive, because simply looping, I'm just going to loop through and I'm going to call generate procedures for each module that I find. This is not the right context. I think we need I think we need to pass in a module. Yeah, I think we need to go like that, because we need the references, which are on the generation, on the context. So, and then we need to pass the module into here. My God, I'm bad at spelling module. Like that. And then we get the correct context that we need. And then we can say, generate the procedures for these other modules that we reference. The reason this is naive is because we might directly reference a module, and then it might also get indirectly referenced, which means we would generate a module twice, which would be a problem. But right now, I think this is fine. And we need to, do something similar for statements. Not that I think we have any statements actually in anything but our main, like there's no statements here. Well, I guess there's this vec3 actually. Okay, let's do it. Generate statements. Wait a minute. Generate procedures should generate procedure. I don't know how that happened. I know why. It's because this is the loop that we should have here. Here, I guess. And generate procedures should be there, and this should be generate statements. Because we need to pass the file into these. So this does the same thing, but it generates the statements for other modules first and then the current one. I don't think we need a pointer there. I guess we need to pass file into these as well. Okay, let's see what happens. Hey, that works. Okay. My confidence in this is not strong. Hopefully this stuff will get cleaned up as we go. I think we're going to need to do a bit more on modules pretty shortly. That was just a really hacky way of getting it together. So now we have that this is importing standard lib, which is why standard lib is getting compiled. And we have to prefix with standard lib. Not that the assembly actually has any namespacing. So if we made a vec3 here, like if we made a struct in here, no, not a struct, because that's a type. So we've got a variable here called FPS time val. No, that's not going to be a problem either. I guess it's a function, right? Functions. So if we made thread pool worker like that, we'll probably get thread pool worker redefined. Yeah. So we don't actually have proper namespacing. That's one thing we should figure out. And then we need to do like deduplication. So we're not importing duplicate stuff or generating duplicate stuff. It would also be nice if we did not generate stuff we're not using. Like this test file has all of the procedures in it, I think. Well, we're not running our tests, are we? Oh, do I dare to do that? We're already in half an hour. Assert not defined. Yeah. Because we need to prefix it. And at the start of our procedure, we need to have, or at the start of our test, we need to have standard lib equals import standard lib. So I guess one of the bonus things with this is that because we have a static, just like a global list of imported things, we should only actually have to process standard lib once. So it should speed things up a bit. I don't know how much it will speed them up, but hopefully the tests will be faster now. Fingers crossed they work. It'll be a pain in the ass if I have to start fixing tests. Come on. Hey, nice. The tests work. We happy. We happy. Got another rogue window to close. Okay. Whew. We did quite a lot there. I guess I'll just call those features now. Yeah, what did we do? We cleaned up our returns. They're much better. We also cleaned up like the not situation, so that can work. So we kind of cleaned up our calls, actually. Type checking of calls is nicer. and we got a rough implementation of modules working, which will need more work, but we got a rough start. So I think that's a pretty awesome session. It was long, but productive. Okay, that's it. Thanks for stopping by. Have a good one. Ciao for now.